Welcome back. Here is our last lesson covering Unit 2, our volume and surface area. So here we are sharing our screen. Okay, here we are on page 42 of our lesson, where we're looking at volume and surface area, problem number 10. So it says formulas for regular figures. We're going to be looking at rectangular solids, which we call a box, sphere, which we also call a ball, cube, a cylinder, which we call a can, and a cone. Now they're going to use these words interchangeably on the test, your homework, so make sure you're familiar with the official words as well as the lay words, okay? So here we go with our first example. It says, given a box with dimensions of 1 foot by 6 inches by 2 inches, find the volume and surface area, including units. So they tell us they want us to find the dimensions of this box. So the lay word is box, but we're talking about a rectangular solid. You notice they didn't give us a picture. You can go to your formula sheet and you're going to go and find a rectangular box. And that's going to be down at the bottom. Here it is. So they want us to find the volume and surface area. So here's the formulas. Let's write them down. So we have volume equals length times width times height. And then surface area equals, paying attention that you have 2 times length times width plus 2 times width times height plus 2 times length times height. Right? So you have 2 L's, 2 W's, 2 H's represented in your problem. Let's write those. So 2 times L times W plus 2 times W times H plus 2 times W plus. Now, I think I wrote that incorrect because I have 3 W's, don't I? Sure do. Again, love the fact that you're going to have that formula sheet. It should be L times H. There we have it. Now we have our formula. Now, if you want to draw a picture, draw a picture. Then sometimes it helps us to put us in perspective of where these dimensions go. So here's our picture. Again, it's not rocket science. Okay, so you can, again, be looking at your formula sheet, copy it from there. Right. So here's our box or rectangular solid. And they tell us that our dimensions are 1 foot by 6 inches by 2 inches. So here's our 1 foot by 6 inches by 2 inches. It's logical. Okay. Now, taking a look at what they give us. If you notice, here they gave us 2 inches, 6 inches, 1 foot. Right there, something's not right. We see that the dimensions are different. Right there, we have a conversion issue. So we know, step 1, we need to convert Now, here we can convert from feet to inches or inches to feet. Since we have two of our dimensions are already in inches, it kind of makes sense to convert the feet to inches, right? That's only one thing that we have to convert. When you're reading your problems in the homework or on the test, make sure you're paying attention to what they want you to have the dimensions in. And what they're going to do is ask you in your final question they give you, they're going to ask you to put your answer in a certain dimension. And that's going to tell you what you need to do. So they may ask you, give you something in one dimension, and then ask you to tell the price of it in another dimension. Right there, you know that you should go ahead and do your conversion to the dimensions that the price is in, because that's what your final answer should be in. That makes sense. Okay, when you start looking at the homework problems, you'll see what I'm talking about. You got to read and pay attention to what they want your answer to look like, how they want it represented with your dimensions. All right, so let's do a little conversion. So let's take that 1 foot, and we know it equals how many inches? That's right, 12 inches. So let's go ahead and make this 12 inches. So now everything is in inches. Now we're ready to go. So now our second step, we can go ahead and we can find our volume. So volume equals length times width times height. So we're going to go ahead and multiply those things together. So our length is 12 times 6 times 2. All right, 12 times 6 times 2 is the same as 12 times 12, so that should give us 144. 144 inches. Now, we're dealing with a volume here, or three-dimensional figure. So three-dimensional means that we're going to cube everything. Before, we were dealing with the two-dimensional figure. When we deal with area, when we're dealing with the inside of something, then we're going to square it. So when we're dealing with something that is inside and raised up, then that's cubing it. So volume is always in cubic units, and area is always in squared units. Okay, so cubic units. If you get anything right on the test, anything right on the homework, it should be the units. Okay, so your volume, 144 inches cubed. All right, so now let's do our surface area. So number 3. So our surface area, again, here we are, making sure we plug in correctly. It helps, we already labeled them, but here it is, making sure that we get it correctly. Our L equals our 12. This is our W. This is our H. And we're plugging into our surface area formula. So we have 2 times our L, 12 times 6, plus 2 times 6 times 2, plus 2 times 12 times 2. There's our plugin. Now you can do this all in your calculator, use your parentheses functions, or you could just do 3 individual areas and then add those things together. All right, so if we do it that way, then we have 6 times 12 times 2. 6 times 2 is 12. 12 times 12 gives us the 144. Then we have 2 times 2 is 4. 6 times 4 is 24. And then plus 2 times 2 is 4. 4 times 12 is 48. Add all that up and we get 216. We're back to area now. So surface area means squared units, inches squared. So 216 inches squared. So when we're working through our problems, remember, this will go good on a flashcard if you're using flashcards to study. Perimeter, no action on the units. Area, anything. So regular area, surface area, units are squared. Volume, the units are cubed. So regular units, no action, squared, cubed. Very simple. On the test, you're going to have 2 parts. I'm going to ask you to put your answer in and then have a drop-down menu to pull out the units. So even if you're not sure about the number, you can at least get the points for the units. Okay. All right. See if we can go to the next page. Okay. All right, here we are, continuing on with number 11. So now we're really going to be working our formula sheet. It says find the volume. Get my pen back. Find the volume of a sphere whose diameter is 54 centimeters. So again, they didn't give us a picture, but here we don't really necessarily need one unless you want to draw one. You're going to have your formula sheet. Making sure we note that they want us to write our answer in terms of pi. All right, let's go and get our formula for the volume of a sphere. All right, so a sphere is right here. Right, so the volume is 4/3 pi r cubed. So 4/3 pi r cubed. So volume equals 4/3 pi r cubed. They gave us a diameter. Make sure you pay attention to what they're giving you now. So the diameter equals 54 centimeters. With our formula, we see that we need a radius. So if the diameter is 54, then the radius is going to equal 54 divided by 2. And that's going to give us 27. So now we have everything we need to complete our formula. Here we are plugging it in. So 4/3 pi. Here's the plug-in of our radius, 27 raised to the 3rd power. Now, in your calculator, you have a hat button, or so the hat button is called raised to. Okay, so you're going to put that in with your 27. Now, feel free to go old school with it if you want. 27 times 27 times 27. That's fine. Okay, but you have a raised to button, so you can use it. So again, remember, this is all over 1. So all you're doing is multiplying across and then dividing by your denominator of 3. So 27 raised to the 3rd, put that in your calculator. 27 raised to the 3rd, push enter, get that number. Then we're going to multiply it by our 4. Push enter. And then divide by our 3. Press enter. If it came out to be a funky decimal, then we know we're going to try and see if we can write it as a reduced fraction. But here it came out to be a whole number. The number you should have gotten is 26,244. All right, 26,244. Remember, we're dealing with volume, and the dimensions they gave us was centimeters. So we're talking, oh, don't forget my pi. You're right. Thank you. All right, 26,244 pi. And then centimeters cubed. All right. And there's our response. So if you need to draw a picture, do it. But sometimes you don't need to draw a picture. You just need to look at the information that they give you and then decipher it and make sure you're plugging it into the right place. All right, number 12 says, find the volume of a cone. We're looking at the cone now. That is 8 meters tall with a diameter of 8 meters. So let's go get the formula for the cone. So here we are looking at our formula sheet, and here's the cone right here. So the cone is 1/3 pi r squared h. So volume equals 1/3 pi r squared h. Now let's pull out our parts. So it says it has that is 8 meters tall. So they're telling us that the height equals 8 meters. And the diameter is 8. So D equals 8 meters. Again, we need a radius. So if the diameter is 8, then our radius is 8 divided by 2, which is, 4 meters. So now we have all of our parts. Now let's go ahead and plug it in. So we have volume equals 1/3 pi. Here's the plug-in of the radius. Remember that value. So we have 4 raised to the 2nd times the height, which is 8. Okay. Then we can go ahead and evaluate. Again, if it makes you feel better to put these over 1, go ahead and do it. We have 4 squared. So doing that in your calculator, we got 4 squared is 16 times that 8. We're going to enter it and get that answer. and then divide by 3, see what we get. And I get a weird, long, funky decimal, okay? So right there, I'm going to see if I can write that as a reduced fraction. So use your toggle button. Remember, you're either going to use your F to D or S to D, or you have your toggle button that's right near your enter sign. If you're in a graphing calculator, it's in your math button, that first selection. All right, clicking it, seeing what it gives us. All right, should give you improper, but if it gives you a mixed fraction, your calculator can write it as an improper fraction as well. So my TI-30X2S calculator gives me a mixed fraction of 42 2/3. I want it to be improper. So there is a conversion button right underneath your F to D button. So you have a PRB button called probability. PRB, that's the button that you use to push in your second function to get your toggle button. Right underneath it, you'll see a mixed fraction to an improper fraction. So push your second function, push that button, and then enter, and it'll change it back to an improper fraction. And we'll see, we'll get right back to that 128/3, which is what we had when we multiplied 4 squared times 8. So 128 all over 3. Don't forget our pi. And then our dimensions are meters, so meters cubed. All right, how are we feeling about it? Our calculator is going to be our friend. Again, I can't stress it enough about you using your calculator that you're going to use on the test. Practice with that calculator. Again, if you have trouble, ask your instructor for assistance, or the Learning Commons members will help you. Okay? But do it before the test. All right, number 13. Find the volume of a can that is 5 inches high and has a radius of 2 inches. So now we need the can or cylinder. So let's go to our formula sheet. I'm going to come up a little bit, and I see it right here. So here's our can or our cylinder right there. And the volume is pi r squared h. So volume for that, V equals pi r squared h. They tell us that h equals 5 inches and the radius of 2 inches. So r equals 2 inches. Now look, in this case, they gave us the radius already, so we don't have to find it. That's very nice of them. Now we just got to plug it in. So we have volume equals pi. My radius is 2. I'm going to square that, and then my height is 5. Doing our calculations, here we have 2 raised to the second power is 4. 4 times 5 is 20. So we have 20 pi, and then inches cubed. So 20 pi inches cubed. You can say cubic inches as well. Okay? And we're done with that one. That one's pretty good. Next one, we don't have fractions, right? But it's okay. We can work around having our fractions. All right. So we looked at these individual forms. our cone, our sphere, and our can. Let's hit up these last two problems where we're looking at our composite figures for the volume. So find the volume of the following composite figures. Give your answer in exact, right? Exact answers in terms of pi. Now look at our figure now. Our figures are composite figures, but they are now three-dimensional because we're finding the volume of these now. Looking at what we have, you should see in this particular picture that we have a cone and we have a half a sphere. We call this a hemisphere, but we could just say half a sphere. Okay, so we have a cone and a sphere, and they want us to find the volume of it. Here we are having to write our structure out again. It really helps. So let's write out our structure. Our structure. So we want to find the volume. We need to find the volume of a cone and then add that to the volume of 1/2 a sphere. That's our structure right there. Now we got to go and get the formulas to support it. And we're doing it just like we did with the area, okay? But now we're using the volume of a cone, volume formula for the cone and the volume for the sphere. Now watch it, we need only half of it. Here we go. To our formula sheet, we need the volume of a cone. The volume of a cone is 1/3 pi r squared h. So 1/3 pi r squared h. That's my cone. Plus, now I need the formula for the sphere. Coming on down here. So the volume for the sphere is 4/3 pi r cubed. All right. So we only need 4/3 pi r cubed. Okay. There's our formula. Doesn't hurt to double check after you finish writing everything. And that works there. Okay. But now remember, with our sphere, we only need half of it. So I'm going to multiply this by half. Now you can use parentheses or brackets here, but I'm just going to multiply with our multiplication sign by 1/2 because I'm going to show you something that's going to help get rid of one of those fractions. So now we got our formulas. Now we need to get our parts. All right, so we know the height of the cone. Do you see that there? 15. And then we know the radius, 10. So we're good to go with the cone. Then the sphere, we only need to know the radius of it, and we have that right there. So we're good to go with all our parts. Now let's start plugging it in. For the cone, we have 1/3 pi. Then the radius for that is 10. We got to square it, and the height of it is 15. Plus, now look at this. We have 1/2 times 4/3. In order to simplify this part so I only have one fraction there, I'm going to go ahead and say 2 can go into 4 2 times. And that way I can get rid of this fraction right here and I only have one fraction there. Because that's one less, right? So I really have 2/3 pi. And then I'm plugging in my radius for the sphere, which is 10. And I have to raise it to the 3rd power. Okay, now soak that up. Making sure you see what I did where I got my information. I plugged in to the appropriate formula. So now we're ready to use our calculator to evaluate everything. Okay, let's go ahead and do it. Now, I don't want to make my work a whole lot harder than it needs to be. So if you can simplify some stuff, if you can, go ahead and do it. Just like I did with these fractions here, and I simplified them. Go ahead and simplify them so that you can have less work. Makes your work a little more streamlined. Looking at this first part here, evaluating it, I have that 1/3, and then I have that 15. Doesn't 3 go into 15? I think I want to go ahead and do that. You don't have to do this. You have your calculator to back you up. But because I'm comfortable with it, and you can start where you're comfortable, I'm going to go ahead and simplify that right here. 3 goes into 15 5 times. So now when I evaluate this first part, all I'm looking at is 10 times 10 is 100. And 100 times 5, that's 500. 500 pi. Did I need the calculator for that? No, I didn't. But again, you have the calculator to back you up. Now let's take care of the second part. Plus. We have 2/3 pi times 10 raised to the 3rd power. 10 raised to the 3rd power, isn't that 1,000? Check it out on your calculator. I know you don't want to believe me. 10 raised to the 3rd power is 1,000. All right. So then 1,000 multiplied by this 2, that's 2,000. And then I'm going to leave it right there. You can leave it as 2,000 all over 3 with your pi. Now we're not finished now because we have like terms there. But if I had did 2,000 divided by 3, I would have gotten this really, really funky decimal. And I'd be like, oh gosh, I don't know what to do with it. Okay, well, you might not right then, but we're going to know what to do with it right now, because we're going to take that and we're going to add 500 to it. So go ahead and put it in your calculator and let the calculator do the work for us and see what happens. So we get 2,000 divided by 3. Let's see what our calculator can do. Plus 500 equals that funky decimal, starting with 1166. Now we're going to use our toggle button to see if it can write it as a reduced fraction for us. Oh, wow. My calculator, it won't be able to write it as a reduced fraction. Sometimes our calculators, memories are not strong enough or big enough to handle certain numbers. So make sure we pay attention to what's going on and what's happening. We might have to go old school on it. I know they want us to do too much math on this one. Okay, but sometimes we just got to do it to streamline it, because you can't leave it as this decimal because they're not asking us to do that. They want us to write an exact answer, and an exact answer is a simplified fraction. So when we're combining these two things, we can't do it with our calculator if it won't be able to write it in a reduced fraction for us. So we have to write it ourselves. Let's see how we're going to do it. So now we got to go old school now. Okay, so now old school, new school, I don't care what school you know, but we have to know that when we combine like terms in their fractions, they have to have a common denominator. Okay, so we see that this denominator is a 1 already, but this is a 3. So our common denominator is 3. So in order to make this a 3, I'm going to multiply it in the form of 1 by 3 over 3. Now this is old school. New school would say, take 500, multiply it by 3, and then take that number and put it back over 3. We're doing the same thing right here. So we're going to get 3 times 500, 1500 over 3 pi, plus, bring this down, 2000 over 3 pi. Right? We're still good? Now you see that we can combine these terms now. Now they have the common denominator, and we can go ahead and take it on home. So to get our volume, adding these together, going across here, we get 1500 plus 2000 gives us 3500 all over 3. Is everybody okay? Then your pi. So now we have 3500 over 3 pi, and then our dimensions are centimeters cubed. I know, they reached back with that one. But if your calculator can't support, in order to write it as a simplified fraction, you're going to have to go back and do it yourself. So make sure you refresh on how to write or to find a common denominator so that you can combine your like terms. All right? Okay, there we go. So we have 3500 all over 3 pi, then centimeters cubed. Right? Our last one for our lesson. Here they give us a cylinder, you see it? And it has a cone on top. They want us to find the volume. So volume equals, here's my structure. So volume equals the volume of a cylinder plus the volume of a cone. All right, so now we got our structure, we need some formulas. Remember, the volume of a cylinder was pi r squared h. So pi r squared h. And then the volume of a cone was 1/3 pi r squared h. So plus 1/3 pi r squared h. So now we have our formulas. Now we need to check to see if we have all the pieces. Let's take a look. For our cylinder, we need a height. Do we have it? We do. Do we have a radius? We do. Sounds good. For the cone, we need a height. Do we have it? Yes, they're telling us right here how high it is. And then the radius, do we have it? We don't see it up here, but we see it down here. So yes, they gave it to us. Now let's plug in some goodness. Making sure you're paying attention, you're plugging the right stuff into the right formula. So for our cylinder, all right, so we have pi. We need the radius. The radius is 40. But then we have to square it. And then our height, 50. Okay. Now let's get that cone. Plus 1/3 pi. Then we have the radius of our cone is 40. And the height of our cone right there is 30. So the radius is 40. We got to square it. I almost forgot that. And then the height is 30. Always go back and do a double take. Make sure we got everything right. Okay, now we're ready to evaluate. Go ahead and see if you can evaluate this thing. Take it on home. It's our last problem. And make sure you pay attention to what you're writing, how you're putting it into your calculator. Very important that we know how to use our calculators. Right? Okay. All right, we should be about there with some possible numbers. It's going to check it in just a second. Should come up with some nice size numbers now. All right, let's talk about it. We should be there. Okay, so here we are with 40 squared. So 40 squared, remember we got that hat button, or you have a squared button now, so you can use either one now. You get 1,600 times 50, right? And you should have gotten, we get it? Should have gotten 80,000. Did you get, yep, you did? Okay, good. 80,000 pi, right? Now, dealing with this next one with that 1/3, remember, go ahead and do your stuff, or if you want to go ahead and simplify here, you can, okay? Totally up to you, right? In fact, I'm going to do it right there. I feel somebody wants me to do it. 3 goes into 30. How many times? How many times? Okay. 10 times. All right, so now we're evaluating. So we get 40 squared. All right, and then times our 10. All right, and we should have gotten our 1,600. But now 1,600 pi. So plus 1,600. Oh, sorry, 16,000. I know, right? It's 16,000 pi. Okay. All right. Double check. If you have some trouble right here and you still didn't get those values, go back right now and re-enter into your calculator, taking your time to see if you get these values. Because right here we see that we have like terms, and now we can go ahead and add these two things together. And when we add them together, we should see that we get our volume to equal 96,000 pi. Okay, so 96,000 pi. And you notice they didn't give us any units here, no dimensions there, so we're going to use just units. And then we know that we got to take action on those, and we're going to cube them. That's right. So that's what we get for our final result. It's not difficult. If there's a challenging looking part, it's the actual working of the formula, just the algebra part. So if you're still weak or lingering on that, please go to the Learning Commons. They have some great handouts. Go and check it out. Talk to them about it, and they can send them to you, direct you to them. Talk with your instructor for more guidance. I hope these videos are helping, and make sure you're getting prepared to study for your tests. Make sure you are focusing on looking at the test reviews that is located on the next page right here. When you are ready to start reviewing, okay? Your instructor will release the answer key to you at the proper time. All right? Good luck with everything, and I'll see you on the next go round.